Hello mathematicians, today's video is on Objective 118, which is solving proportion word problems. So our objective today is students will be able to solve proportion word problems. Go ahead and pause the video if you need to and copy down the objective. Press play when you're ready and we'll start the notes. So we are doing Objective 118 today, which is solving proportion word problems. Before we kind of get into how we solve proportions, let's go ahead and define a couple of things. So the first one we're going to define is the word ratio. And a ratio is a comparison of two numbers. A comparison of two numbers that have a relationship. So it's a comparison of two numbers that have a relationship. So let's talk about what an example of a ratio might be and the different ways that we could see it written. And I'm going to zoom in so we can get a little bit closer for that. So, for example, we sometimes see ratios written as fractions. For example, I could say the ratio of boys to girls in my class. I might say the ratio of boys to girls is 11 to 16. There's 11 boys and there's 16 girls. We also sometimes see ratios written with a colon. So again, I might say the ratio of boys colon girls. The ratio of boys to girls is 11 to 16. The last way we sometimes see ratios written is the word to. So I might say the ratio of boys to girls, or I could say 11 to 16. So all of those are different ways to write ratios. You might see ratios written in different ways. So I want you to think of, you could see it as a fraction, you could see it with a colon, you could see it with the word to, but all of them mean the comparison of two numbers that have a relationship. All right, now what is a proportion, which is what our objective is about today? A proportion is two equivalent ratios. So if a ratio is comparing two things like boys and girls, we might say a proportion is two equivalent ratios. For example, I might say Mr. Irwin's class has 5 boys and 10 girls. Miss Moran's class has 5 boys and 10 girls. So the ratio of boys to girls in my class is the same as the ratio of boys and girls in Mr. Irwin's class, and that would make them both proportional. So to find out if two things are proportional, we are going to use cross multiplication. Now we're familiar with cross multiplication. We've done this before in some of our other objectives, but I want you to think of it, I also kind of refer to it as the butterfly effect, and when we go through the steps in a few minutes, you'll see why we call it the butterfly effect. But let's just kind of talk about what our results are going to mean. So when we cross multiply, if our cross products, that means after we cross multiply, if the two numbers we times by each other are equal, if our cross products are equal, then the ratios are proportional. If our cross products are equal, then our ratios are proportional. And let's fix the word proportional there. Okay? If the cross products are not equal, then the ratios are not proportional. So if our cross products are equal, then the ratios are proportional. If the cross products are not equal, then the ratios are not proportional. Okay? Remember, a proportion is two equivalent ratios. So we're looking at two things being compared, and we're seeing, are they equivalent? Are they proportional to one another? So let's go ahead and do some examples to see, are things proportional? And it'll make a little bit more sense. All right, so we have example 1, and I'm going to zoom in. We have our two ratios. We have one ratio, which is 0.4 over 0.8. Our other ratio is 0.7 over 1.4. To figure out, are these two ratios proportional, the first thing we're going to do, and I'm going to write our steps here, is we're going to set them equal to each other, because we have to set up a problem that we can use cross multiplication. So first we're going to set them equal to each other. Second, we're going to cross multiply. And third, we're going to simplify. And we'll see, are their cross products equal? So I'm going to zoom in a little bit more so that I can write a little bit clearer. Okay, now this is why I call it the butterfly effect. What we're doing is we're going to multiply the numerator of one fraction by the denominator of the other. So we're going to multiply the numerator of the first fraction by the denominator of the second. We're going to multiply the denominator of the first fraction by the numerator of the second. And it kind of forms a butterfly almost, okay? Now remember, we need to set these equal to each other. So I'm going to put an equal sign in between. Okay, and that was actually step 1, set them equal, cross multiply. And so I'm going to say, okay, I'm going to do 0.4 times 1.4, and that's going to be equal to 0.8 times 0.7. Okay, I've set up my cross multiplication. Now I need to simplify. 0.4 times 1.4 gives me 0.56. 0.8 times 0.7 gives me 0.56. Now, are the cross products equal? Yes, we got 0.6 on the left, we got 0.6 on the right. So our cross products are equal, which makes this a proportion. Our two ratios are equivalent. Let's do another example. Let's look at example 2. First thing we're going to do is set them equal to each other. And then we're going to use the butterfly effect. I'm going to multiply 6 times 28, the numerator in the first times the denominator in the second. I'm going to multiply 8 times 24, the denominator in the first times the numerator in the second. Set this up. 6 times 28 equals 8 times 24. And I'm going to simplify. 6 times 28 is 168. 8 times 24 is 192. Now I'm noticing that these cross products are not equal. They do not give you the same number, which means that these two ratios are not proportional. Not proportional. Another way of thinking about this, and I want to show you this before you move on, is to think about, it's kind of like looking at equivalent fractions, okay? And I'm going to kind of put a third example over here that I want you to draw in. This is going to be example 3, and I'm going to show you a little bit of a different way to do this. Let's say I had given you something like 2/4. Is that proportional with 6/12? Okay? Now, we could cross multiply, right? Another way of thinking of this is when we cross multiply, we're basically figuring out, are these two ratios proportional? And if they're proportional, they should reduce to the same decimal. So if I reduce 2/4, I get 0.5. If I reduce 6/12, I get 0.5. Okay? So another way of doing this is just changing the number into a decimal. 2 divided by 4 is 0.5. 6 divided by 12 is 0.5. If we were to practice this and cross multiply, we would see that this also works, because we could do 4 times 6 equals 12 times 2. 4 times 6 is 24. 12 times 2 is 24. Okay? So if you also want to think about reducing your fractions or your ratios into decimals, it also works that way. Okay, I want you to do a little bit of practice. So I actually want you to do all 4 of these practices and tell me, do the following ratios form a proportion? So go ahead, set each of these examples equal to one another, cross multiply, and then press play when you are ready to see the answers. All right, here are your answers. You should have had yes for practice 1, no for practice 2, no for practice 3, and yes for practice 4. Remember, I just showed you the answers, but when you come into class, you should have work next to all of these problems, because you should have paused the video and practiced them. Okay, next we're going to move on to solving of proportions when you're giving a variable. Solving a proportion when you're given a variable. So this is very similar, but just slightly different. We're still going to use cross multiplication, but this time we're solving for an unknown, a variable of some sort. So let's first try out some steps. Our step number 1 is to cross multiply. Step number 2 is to simplify. Step number 3 is to solve for your variable. And step number 4 is to check. Okay, so let's go through our first example. So the first thing we want to do is cross multiply. So I'm going to do 16 times n, 24 times 15. Go ahead and set that up. We're going to have n times 16 equals 15 times 24. Now we're going to simplify. Now, we've talked about we want to have our coefficient 16 in front of n. So I'm going to rewrite this as 16n equals 15 times 4, which is 360. Now I'm going to solve for n. I'm going to make a quick do and undo box. What's happening to n right now? It's being multiplied by 16. How do you undo multiply by 16? You divide by 16. So I'm going to divide both sides by 16. My 16s cancel out. I'm left with n equals, and 360 divided by 16 is 22.5. Okay, so we think n equals 22.5. Let's check, and here's how we can check. And check is really important because it can help us make sure that we have the correct answer. Our first fraction, originally we had n over 15 equals 24 over 16. And what I'm going to do is I'm going to put n, 22.5, in for n. So 22.5 over 15, does that equal 24 over 16? Now, you can do one of two things to check. Remember, if the two things are proportional, which they should be because we're solving a proportion, our cross product should be equal. So we could try, okay, what's 22.5 times 16? And does that equal 15 times 24? Well, 22.5 times 16 is 360. 15 times 4 is also 360. So our cross product equal each other. It works. Your other option is to take your two ratios that you set up, so 22.5 over 15 equals 24 over 16, and reduce them, change them into decimals, and see if you get the same decimal. So 22.5 divided by 15 gives me 1.5. 24 divided by 16 equals 1.5. When we reduce our fractions, they are equal. So our check works, so our answer is 22.5. All right, let's move on to example number 4. I'm going to do our second example. So first thing I need to do is cross multiply. So I'm going to do 22 times 5, 9 times x. So 9 times x equals 22 times 5. Okay, and it doesn't matter which side you put the 9x on and which side you put the 22 times 5 on. Either one is fine. So 9 times x is 9x. 22 times 5 gives me 110. Now I need to reduce and solve for x. I'm sorry, not reduce, simplify and solve for x. So what's happening to x? It's being multiplied by 9. How do you want to do multiply by 9? I'm going to divide by 9. So I'm going to divide both sides by 9. So x is going to equal 110 divided by 9, which is 12.2 repeating. 12.2 repeating. Alright, let's check to see if it works. Now, because you got a repeating decimal, when you check this, it's going to be a little bit different. When you set up your fraction, you're going to put 12.2 over 2 over 22. Actually, let's make it so that we have the same one on both sides. So we originally had 5/9 on the left. So we had 5/9 over x equals x over 22. So 5/9 is going to be equal to 12.2 repeating over 22. Now, when you check this in your calculator, you have to find a way to show that you have a repeating 2. So I want you to think back. What gave you 12.2 repeating was this 110 over 9. So when I check this, I'm going to use the method of just reducing my fractions. So first I'm going to reduce 5 over 9. And when I do 5 divided by 9, I get 0.5 repeating. Okay? Let's actually write this down here so I can show you something. We get 0.5 repeating. Now, when I try to check 12.2 repeating over 22, what I'm going to put in my calculator is this. 110 over 9 divided by 22. That's going to allow me to get that 12.2 repeating. And when I do that, I get 0.5 repeating. So our check works. So x equals 12.2 repeating. All right, I want you to practice. And I want you to try these practices up here. Practices 1. So go ahead and try practice 1, 2, and 3. Pause the video. When you're ready, press play and you can see the answers. All right, here are your answers for the 4 practices. Practice 1 was 8. Practice 2, 8 equals 15. Practice 3, n equals 4.62. And this should say practice 4, but that 4th practice was x equals 4.6 repeating. Make sure that you have a repeating sign over your 6. That's the end of our video. Make sure you write down any questions that you might have and come to class ready to practice.